So yes, now we will be we're done with this. Now we'll be discussing the SLAAC and DHCPv6. So I think we don't have here the packet tracer, but packet tracers we have only one lab activity. So I was wondering if I also do lab activities. So let's see if we have more time, but I will be doing some of my final projects on the other subjects, but let's see. Okay, so SLAAC and DHCPv6. So in the last module we will discuss the DHCPv4, so we will do a review there. Okay, so introduction is the SLAAC and DHCPv6. So what will I learn in this module? So module name, and then the objective is configure dynamic address allocation in IPv6 networks. So it's much similar to DHCPv4, but the only difference is we are configuring router with IPv6. Okay. So we're talking about IPv6, not IPv4. Okay. So we have here 4 topics for this module. We have IPv6 GUA assignment, so global unicast address assignment. So it's the same with IPv4 address. Then we also have the SLAAC, DHCPv6, and configuring DHCP server. Okay, so we have here the objective for each topic. So we need to explain IPv6 host, how an IPv6 host can acquire its IPv6 address, the operation of SLAAC and DHCPv6, and also configuring stateful and stateless DHCPv6 server. Let's see. Okay. So IPv6 GUA assignment. So on a router, an IPv6 global unicast address, so it is the IPv6 address, the literal IPv6 address. So it's similar with IPv4 address, the routable ones. So it's manually configured. So this address is manually configured using IPv6 address, the address, and then the prefix length. So in the global config. So Windows host can be manually configured with an IPv6. Okay, so this is in Windows host. So we have here the IPv6 address, the subnet, default gateway. So we will so in this figure it is manually configured. Okay. So manual entering on IPv6 GUA can be time consuming and somewhat error prone. So therefore most Windows hosts are enabled to dynamically acquire an IPv6 GUA configuration as shown in the below. You can see that obtain an IPv6 address automatically. So we're not manually configuring it. So IPv6 host link local address. So when automatic IPv6 addressing is selected, the host will attempt to automatically obtain and configure IPv6 address. So information on the interface. Okay, the host will use one of the 3 methods defined by the ICMPv6. So router advertisements message received on the interface. Okay. So we have here the link local address. The reason is so the link local address. So So I think this is the somewhat IPv6 address on the local subnet. Let's see. There is no meaning for LLA. So the IPv6 link local address is automatically created by the host when it boots and the Ethernet interface is active. Okay. So every device with IPv6 enabled is we need the link local address. So IPv6 global unique address assignment. So IPv6 was designed to simplify how a host can acquire its IPv6 configuration. So by default, an IPv6 enabled router advertises its IPv6 information. Okay, so this allows a host to dynamically create or acquire its IPv6 configuration. Okay, so we have here the router advertises its IPv6 information. So the IPv6 global unique address can be assigned dynamically using stateless and stateful services. So when you say stateless, no device is tracking the assignment of IPv6 address. Then stateful is we have the server managing the assignment of IPv6 addresses. So we have also two types of stateless assignment. We have the SLAAC only. I think the only device involved here is the the router. So it sends router advertisements. So the router provides all the information. So the information is on the router advertisement. Then the SLAAC with DHCP server. So I think we are using the router and the DHCP server. Okay. So we are getting also information from the router, but we also need the DHCP server for additional information for IPv6. Now for the stateful, so under the stateful is the DHCPv6 server or the stateful DHCPv6. So all our information will be given by the DHCP server. Okay. So the host contacts a server to acquire all of their IPv6 addressing information. So on the SLAAC, we only use the router. SLAAC with DHCP server, we have the router and then additional information from the DHCP server and then the DHCP6 server. So the router provides all the information for IPv6 configuration. So here three router advertisement message flags. We have the A flag, O flag, and M flag. So A flag is the address auto configuration flag. So use stateless address auto configuration SLAAC to create an IPv6 GOA. So this is the other configuration flag. So this is for stateless DHCPv6 server. Then M is for, so it stands for, this is the manage address configuration flag. So it's use a stateful DHCPv6 server to obtain an IPv6 GOA. So for A flag, this is for SLAAC. Then O flag is for stateless DHCPv6 server, or this one. And then for M flag is the DHCPv6 server. Okay, never the RS. The RS is the router solicitation. So I need an RA from R1, so it contacts the router. So the router has three options. So RA options, we have the SLAAC only, stateless DHCPv6, the stateful. As you can see, we have here the A flag is equals to 1 and both O and M is equals to 0. So this means that the RA option is set on SLAAC only, Then for the second one is A and O flag is set to 1, so then M flag is equals to 0. So this means that the router is using this stateless DHCPv6 to provide IPv6 configuration. Then for A flag is equals to 0 and M flag is equals to 1. So the router is using the DHCPv6 server as the IP config, as the for giving IP configuration for the host. So here, check your understanding. So that is by choosing that. So DHCPv4. So I just wondering, because I think I'm having confusion, little confused for IPv4. Okay. We're getting so relay agent. Okay. So which address type is automatically created by default on the host interface when no arrays are received? So I have the link local address. Which method best describes stateless SLAAC with stateless? So this is the stateless, but we don't use the server, so we use the stateless DHCP and then stateful C. So SLAAC overview. So not every network has access to the DHCPv6 server, but every device in an IPv6 network needs a address or global unicast address. So the SLAAC method enables hosts to create their own unique IPv6 global unicast address without the services of the server. So okay, it is a stateless server, so it means that there's no server that maintains network address information. So the SLAAC uses ICMPv6 array messages to provide addressing. So that would be normally provided by the server. So the RS messages are sent by IPv6 router every 200 seconds. So the host can also send the RS or router solicitation for requesting IPv6 address. So SLAAC, so it is stateless and can be deployed as SLAAC only or SLAAC with DHCPv6. So SLAAC DHCPv6 with DHCPv6, so it involves DHCPv6 server. Okay, we have here some syntax. So enabling SLAAC. Verify IPv6 addresses. So read the link local, GOIN, submit. Okay. Then join group. Join group addresses. Assume that R1 gigabit 00/1 has been configured with indicated IPv6 GOA address. So enable IPv6 routing. So we need this to enable the sending of array messages. So our router must join the IPv6 all routers group. So using this command. Enabling SLAAC. So we're enabling SLAAC on the router. Okay, we're enabling SLAAC for this router to provide address for PC1. Okay, enable. Okay, this show command is for router. So the router has GOA. Verify SLAAC is enabled. Here is this. Okay, this is the group. SLAAC only method. So it is enabled by default when IPv6 unicast routing command is configured. Unicast routing. Okay. So all enabled Ethernet interfaces with an IPv6 GUA configured will start sending array messages. So this flag. So A is set to 1, O and M is set to 0. So the A is equals to 1 flag suggests to the client that it creates its own IPv6 GUA using prefix advertised in the RA. Okay, so the information that was provided by the RA is only the prefix. So it is a 64-bit. I think it's a 64-bit information. So I think it is the network address for and then the client will create its own interface ID. So using this method, the extended unique identifier or randomly generated. Okay. Flag value. So the default gateway address is the source IPv6 address of the RA message. Okay. Which is the LLA for router 1. So the default gateway will be the link local address of router 1. Okay. So I think this is the address provided by the router, and this one right here is automatically generated by the host. So ICMPv6 RA messages, so it sends RA messages every 200 seconds. So when a client is configured to obtain its addressing information automatically, it sends an RS message to the IPv6 all routers multicast of FF02. So why did it send RS messages? I don't know. Okay. So figure illustrates how a host initiates the SLAAC method. Okay, the first one is the PC1 have no address, so therefore it sends an RS message to the IPv6 all routers. Okay, so it is a multicast address, so just discovering a router to provide an IPv6 address for him. So R1 is part of IPv6 all routers group. What is all routers group? All routers multicast group addresses all routers on the same network. So, okay. So basically, this is the all routers on this local subnet. Okay. So this is the address for it. So it is the R1 receives the RS message. So it generates an router advertisement containing the local network prefix and prefix length. Okay. /64. So it provides only this one, the network address. Okay. Then sends the RA message to the IPv6 all nodes multicast address. IPv6 all nodes multicast. So I think this is the all nodes. I think this is all the nodes or all the devices on the subnets. So it is a multicast address, not a unicast address. Okay. So host process to generate interface ID. Okay, so on this SLAAC, it only provides the first 64 bits. So, which is the network address for IPv4. So the other or the remaining 64 bits is randomly generated or by EUI64. Okay. So the host creates an interface ID using its 48-bit MAC address and inserts the X values of the middle of the address. Okay. So in this method, so the host creates its interface ID using the MAC address of its host. Okay. So it's a 48-bit. So 64 minus 48, we have 14. No, 16-bit remaining. I think it is randomly generated. So we have here the randomly generated. So duplicate address detection. So the duplicate address detection is the process used by the host to ensure that the IPv6 GUA is synced. So that is all about. So to perform DAD, so the host sends an IPv6 neighbor solicitation or NS message. So with special constructed multicast address. So the address duplicates the last 24 bits of IPv6 address of the host. So if no other devices responds with the NA message, so this is the NA message or NS neighbor it is the neighbor advertisement message, I think. Then the address is further guaranteed to be unique. Okay. So if NA is received by the host, then the address is not unique. So the OS has to determine a new interface ID to use. So which two IPv6 messages are used in the SLAAC process? We have the router solicitation. Next is which command must be configured on a router to enable it to join the IPv6 or router's multicast address. IPv6 unicast routing. This is for configuring the IPv6 address. Then this is for IPv6 configuring the link local address for IPv6. Then the IP routing is for enabling routing of IP address. Okay. So what are the flag settings when a host uses the SLAAC only? So here the A SLAAC only. Sent by the host to an attempt to locate an online IPv6 enabled routing. So it's RS, router solicitation. Okay, so what method is used by the host to verify the IPv6 address is unique? So we have the DAD, duplicate address detection. Okay, well, got it correct. For the third topic is DHCPv6 operation steps. So here are 6 steps. So the first one is host sends an RS message. So this is the first one. So the router solicitation, the RS message. Okay. So PC1 sends an RS message to all IPv6 enabled routers. So it sends an RS message to all the routers on the local subnet. Okay, this is the DHCPv6. Okay, so it involves the DHCPv6 server. Okay. So router responds with an RA message. Okay. This is a SLAAC method with DHCPv6. So the router advertisement. So it responds with the router advertisement. Next is host sends a DHCPv6 solicit message. Okay, the client now, DHCPv6 client, DHCPv6 client. So now it needs to locate a server and sends a solicit message. The reserved IPv6 multicast all DHCP servers address. Okay, this is a link local scope, so which means routers do not forward the messages to other networks. So this message is only for the local subnet. Okay, solicit to all DHCP servers. So the DHCPv6 solicit is finding a server. Okay. So now the server, the DHCPv6 server, responds with an advertised message. So the advertised message informs the client that the server is available for DHCPv6 service. So after the solicit message, now the server sends an advertised message. So it's a unicast message. So host responds to DHCPv6 server. The PC response depends on whether it is using stateful or stateless DHCPv6. Okay. For stateless client, so it just generates the interface ID, but using the prefix provided by the array message. Then, okay. So after generating the IPv6 address of the host, now the client will send the information request for additional information, configuration parameters such as DNS server address. Okay. So the client is using the server as for completing or configuring some of the parameters or missing parameters, like what I said, the DNS server address. Now for the stateful DHCPv6 client, so the client sends an DHCPv6 request to the DHCP server to obtain all necessary IPv6 configuration. Okay, for the stateful DHCPv6 client, so all the information was provided by the DHCPv6 server. So that includes the IPv6 address, the server, the network address. So I think except for the gateway, default gateway. So now the DHCPv6 sends a reply message. Okay. So the content of the message varies depending on if it's a replying to a request or information request message. Okay. Can be stateful or stateless. We have the stateless DHCPv6 operation. Okay, the stateless DHCPv6 option tells the client to use the information in the array message for addressing. Okay, so this is only for IPv6 address, and then the additional configuration parameters are available from the server. Okay. So we see the flag in the value 11. Then enable stateless DHCPv6 on an interface. Okay, we will use this command IPv6 and the other config flag. Okay, just to enable the stateless DHCPv6 on the interface of our router. So it's like we're setting up the flags to 1 and a flag and no flags equals 1. So we can also use the no IPv6 and the other config flag to reset the interface to default SLAAC on the option. Okay. So using this show command, host use stateless autoconfig for addresses and host use DHCP to obtain. Okay. So stateful DHCPv6 operation. Okay, the RA message tells their client to obtain all addressing information from a stateful DHCPv6 server. Okay, so in stateless and stateful DHCPv6 operation, so the router is also involved just for sending RA message, whether it is stateful, so whether if it's the server will provide all the information, or just for additional information for configuration parameters. Now for enabling the stateful DHCPv6 on an interface, so we need to type in the command IPv6 ndmanage config plan. So the only difference is in this one. So nd other is on the stateless DHCPv6. So as you can see, we have host use DHCP to obtain routable addresses. Okay, what UDP port do DHCP clients to send DHCP6 message? So I think I did not mention that, but the answer is 547. So the UDP port, the clients to server, is 547. So this is the UDP port 547. But from server to client, it is 546. So what DHCPv6 message does a host send to look for DHCP server? So we have the solicit. Advertise is for advertising at IPv6 address. Permission request is for it is a message for requesting additional configuration parameters, and then the request is requesting all the IPv6 configuration from the server. So what DHCPv6 message does a host send to this if it's using stateful? So stateful meaning all the IPv6 configuration is from the server. So we have here host send to server. So we have the request. What flag settings is used for stateless DHCP? Stateless. What flag settings? That one. Check. Reset. We need to reset that. That's a 547. So this is it. Stateful is request. Check. Okay. Configure DHCPv6 server. Okay, we are now configuring the router as a DHCPv6 server. Okay, the router can be configured to provide DHCPv6 server services. Specifically, it can be configured to be one of the following. So you can get the server, client, and relay agent. So it's also the same with IPv4, DHCPv4. So configure stateless DHCP server. Okay. So we have here the steps to configure and verify a router as a stateless DHCP6 server. So the step 1 is the IPv6 unicast routing. So for IPv4 we have IP routing. Yes. So this command is required to enable IPv6 routing. Although it is not necessary for the router to be a stateless DHCPv6 server, it is required for the router to source RA messages. Okay. Next is we need to define the DHCPv6 full name. Okay, we have this command IPv6 DHCP full. The only reference is the v6 here, so we added v6. Then also configure the DHCPv6. We have here the DNS server domain name. The default gateway is none. So DHCPv6 full, so we need the IPv6 address. Domain name. the green arrows. So bind the DHCPv6 port to an interface. IPv6 stateless. What? Okay. It's like we're configuring the pole to the onto an interface. So it has to be bound on an interface. Okay. IPv6 IPDCP server. I think we did not use this one. Okay. So here it is configured as the server. The router is configured as a server. Okay. And then on an interface they use the server. IPv6 address. What? They manually configured the IPv6 address. Why is that? Then verify, and the last step is verify host received IPv6 addressing information. Okay, we're just using the IPv6 configure. IPv6 address. Wait. What is this? ACAD1. ACAD1. I think that is the network address. So now we will be configuring a stateless DHCPv6 client. So the router will receive the IPv6 information from the server. So we also need to enable the IPv6 routing. Then configure a client router to create an LLA. Okay. So using the IPv6 enable is, so when used, also this command when used, so it creates a LLA. Okay. So the client router needs to have a link local address. So an IPv6 link local address is created on a router interface when a global unicast address is configured. Okay, we don't have a link local address for a router in an interface of a router. It also can be created without a GUA, so GUA, using the IPv6 interface. Okay. Configure client router to use SLAAC. Okay. So IPv6 address autoconfig. Okay. So it enables the automatic configuration of IPv6 addressing using SLAAC. So we use SLAAC here. Okay, it's stateless. So I also need to verify the client router is assigned to GUA. Then verify client router receive other DHCPv6 information. So we get this additional information from the server. So since it's a stateless DHCPv6 client. So for the stateful, we have also 5 steps. So the step 1, the unicast routing. Step 2 is the server, IPv6 server. Then the last one is stateless client. Okay, so we're stateful DHCPv6 server. Okay. So the first one is the stateless DHCPv6 server. So for the stateful, so the router will provide all the all the information. Okay. You also need to create a pool. Okay. Address. IPv6 addressing, then the server. domain. Address prefix. Okay. So the address prefix all addressing and other must be assigned by the DHCPv6. Okay. So we also need to bind the pool to an interface. So as you can see here. So we have the manage config flag. So IPv6 ND prefix default na auto config. Okay, the A flag is manually changed from a 1 to 0. Okay. ND prefix default na. So in this part, we only need to cite the IPv6 prefix. Then the step 5 is all about configuring. So if it's received an IPv6 address information. Then for configuring a stateful DHCPv6 client, also the 5 steps. Stateful client. So IPv6 unicast routing. So I need to enable it. So we also need to create a link local address for the router. Then the IPv6 address DHCP. So it requesting some information from the DHCPv6 server. Okay, so we use the show command to verify the host configuration. Okay, so I also need to verify if it receives the other DHCPv6 information, like the server, the domain name. Okay, we have the IPv6 DHCP full and the show IPv6 DHCP. So these are the show commands for verifying IPv6 configuration. So IPv6 DHCP full. Okay, so you can see that IPv6 pool, the name of the pool, the DNS server, domain, and the clients. So for the binding, we also see the clients, then their address. So we can also configure the router as relay agent. So if the server is located on a different network than their client, then the IPv6 router can be configured as a DHCPv6 relay agent. So it's the same with the IP helper address on the IPv4, DHCPv4. But on this is we need to type in this command, the IPv6 DHCP relay destination, the IPv6 address, and then the interface type interface number. 12 G00/2 interface type, IP address of the router 100. Okay. So also need we also have the commands for verifying the DHCPv6 relay agent. So the IPv6 DHCP interface, the binding, So tired. So check your understanding. Which 3 DHCPv6 rules can a router perform? So all of this applies. Which command is not configured in stateless DHCPv6? Stateless. Stateless. What is stateless? Address prefix. I think this is domain name, DNS server. I think we don't use this DNS server. So an IPv6 enable router is to acquire its global unicast address from another IPv6 router using SLAAC. So which interface should be configured on the client router? Okay, so we're using SLAAC. So this two is for requesting from the stateful server. Add this for the client. So routers to provide IPv6 DHCPv6 server services. So which command should be configured on the client facing interface? Okay, so we provide DHCPv6 server. And the other. So on IPv6 enable routers to acquire its IPv6 GUA from DHCP server. So which interface configuration command should be configured on client router? What? So a router is to acquire its from the server. Okay. IPv6 is so which DHCPv6 verification display the local entry. So here the binding DHCPv6 folder our interface. And the IPv6 so is for relaying. Okay, that's all the wrong answers. IPv6 DHCP server. Okay, this is full. Stateless. See. Okay, we got the first enable. What? Server? For IPv6 server, IPv6. Let's see. Server. Should be pool, not server. Module practice and quiz. So here the lab activity. Okay. Then we will be doing also the lab activities. Lab time. So we learn in this module is the IPv6 GUI assignment. Okay. There are also the 3 flags, the A flag, O flag, M flag. So the SLAAC. So it enables hosts to create their own unique IPv6 global unique address without the services of the server. In DHCPv6 and also configuring a DHCPv6 server. Module quiz, SLAAC and DHCPv6. So we have 15 or 12 questions. This module is quite long. So tired reading. So how does IPv6 client ensure that it has a unique address after it configures? So it sends a neighbor solicitation message. Okay. To employ to learn the IPv6. So it uses the link local address. Okay, wait. On the link router, generate an interface ID of the line using the SLAAC to obtain an IPv6 for its interface. After this one. So for SLAAC is the NS. Okay, the neighbor solicitation. So to ensure that the address is unique, so which command should be configured and routed to reset the router stateful DHCPv6 client. IPv6 address DHCP. Don't see this command. Let's see. Copy. Next is what message informs IPv6 enable interface to be stateful. Stateful is advertised. No. Advertise. No. It's router advertisement. So stateful or okay, so it dictates the IPv6 host or devices. So the RA dictates whether it's stateful or stateless. So which destination IP address is used. So solicit message. So group. This is a group for servers, I think. So in which there's a dynamically SLAAC. Okay. So the company implements the stateless DHCPv6 method for configuring IPv6 on local workstations. So after workstation receives messages from multiple DHCP servers for configuration. Solicit. Oh, no. Solicit, no. Solicit is for sending, for locating servers. Setting information requests. Stateless, so it's an information. If it's stateful, it is the request. Okay, what process is in ISIN to verify? So I heard that. Okay. So what are two characteristics of SLAAC method for IPv6 configuration? Okay. So read the first one. SLAAC, so it's not stated for you. Client sends router advertisements. No. Okay. After booting, a client receives an IPv6 RE message with the M flag set to 0 and O flag set to 1. So it is stateless DHCPv6. For more information. Okay. The last question is Sonnet North Unicast routing. Sending I sent. Check. Okay, we already got all correct answers. So the next module would be the FHRP concepts. Oh, okay. We only have two. Okay. So hope this is not long. Okay, and after this we are going with these modules. So these modules I already have the videos for this. So we already take this on the bridging course for SRW. Okay. But we also need to create a new video because to just what's that word? I can say. Okay, so I think that's it.